review and going into the different forms of a linear function. So beginning of the year, well not beginning of the year, in beginning of this actual year, January, February-ish, we started talking about slope-intercept form. So we're gonna review over slope-intercept form and then go into the other two forms, which you will have to know or you will learn in algebra. So remember, I told y'all there are three forms, but we're gonna focus on only one in eighth grade. You're gonna learn the other two next year. So we're gonna do a little lesson on that this week. So slope-intercept form, as you know, is y equals mx plus b. So m is your slope, b is your y-intercept. So that's where b is where my line crosses my y-axis. Slope is my rise over run. So if you remember that from our lesson on that. X is our input or our domain values, our independent values, while y is my output, which is also my range and my dependent value. Y depends on x. An example of slope-intercept form is y equals negative 2x plus 3. 3 is my y-intercept, positive 3 at that, and my slope is negative 2. So if I want to rewrite this as an actual slope as rise over run, it will be negative 2 over 1. Rise 2 to the left of 1 or down 2 to the right 1. Remember, if your slope is negative, your line is going up to the left. If it's positive, it's going up to the right. Now, this is something new. Standard form. This is what you're going to be learning next year in algebra. So standard form is written in the form of ax plus by is equal to c, where a and b are your x and y intercepts. So this form is useful when they give you an x and y intercept. Remember that a, b, and c, which is your variables, or not your variables, which is your values in the formula, is going to be integers. Integers are not fractions or decimals, so it's positive and negative whole numbers. An example of slope-intercept or standard form will be the one at the bottom here. It says 2x plus y is equal to 3. So this and this form here, which is a slope-intercept form, y equals 2x, negative 2x plus 3, the same example we saw in the last slide, these are the same thing. So when you have to write in slope-intercept form to standard form, all you have to do is make sure that x and y are on the same side together. Look at the formula. X and y are together. So in slope-intercept form, x and y are separated. So all we have to do is simply move the coefficient of x to the other side with y using inverse operations. So negative 2x move to the other side. Remember, every time we move something to the other side, it becomes its opposite. So negative 2x becomes positive 2x. That's what you see here. So we have positive 2x plus y is equal to 3. That is the standard form. And then lastly, we have point slope form. This form is very useful when they give you a point and a slope. All you have to do is plug in those values into the formula. So we have y minus y1 equals to m times x minus x1. x1 and y1 is the given point, and m is your slope. So let's look at an example. It says write the equation of the line slope-intercept form. So I have a slope of negative 2 and a point of 2 comma negative 1. So all I have to do is plug in these numbers into the corresponding variable. So I have y plus 1. So as you can see, if I plug in y1, it is negative. And the formula is already a subtraction sign. So a double negative is a positive. That's why this is a positive 1. Is equal to m. My slope is negative 2. So I plug in negative 2 here. Times x, that stays x, minus x1. x1 is 2. So I have minus 2. So that is my formula or my function in point slope form. Let's say you want to convert from point slope form to slope intercept form. So you're converting from one form to another. All you have to do is remember all the concepts you've learned in the past years, including this one. So first, if you convert from point slope to slope intercept form, you have to simply use the distributive property. So again, when you have parentheses and a number or a variable in front, you have to multiply everything inside the parentheses by what's touching the parentheses. So that's called distributive property. Then you're going to move the constant that's with y to the other side using inverse operations and then combine like terms. So let's say we have the same example. Y plus 1 is equal to negative 2 times x minus 2. So first I have to use distributive property. So again, I see my parentheses here. So I need to distribute this negative 2 to both things inside the parentheses by multiplying. So I have negative 2 times x, negative 2x, and then I have negative 2 times negative 2. Again, a double negative is a positive. So positive 2 times 2 is 4. That's how I get my positive 4 here. Next, I need to move the constant, which is the number that's with the y variable, to the right side. So again, I have a 1 here. I have 1 here, positive 1. So I need to move that positive 1 to the right side. So positive 1 becomes its opposite if it's moved to the other side of the equal sign. So it becomes a negative 1. That's how you get minus 1 right here. So I have negative 2x plus 4 minus 1. And then finally, I need to combine my like terms. So constants go with constants, variables go with variables, which other means x's go with x's. So I have a positive 4, which is a constant, and the negative 1, which is a constant. So I have 4 minus 1, which gives me a positive 3. So that's how I get negative 2x plus 3. So every form we did are the same function. So y equals negative 2x plus 3 is the same function as y plus 1 is equal to negative 2 times x minus 2. And it's also the same as the standard form we had, which was 2x plus y is equal to 3. All those are the same exact line on a graph. And then we have a recap of those formulas. Slope-intercept form y equals mx plus b. Point slope y minus y1 is equal to m times x minus x1. And then our standard form ax plus by is equal to c. That's it. See y'all later.